In this demonstration, we'll look in more depth at some of the built-in functions that Excel has. In particular, we'll start with trigonomical functions and how Excel deals with radians and degrees. We'll then move on to looking at rounding functions, in particular how the rounding functions differ from the formatting we saw earlier. We'll then finish with some basic statistical functions. However, to start with, I'd just like to remind you on how you access these functions. Previously, I showed you that if you started typing with an equal sign to get into our formula mode, in this case, I'm just going to start typing sum. We then can access this list of functions starting with the word sum. If we wanted to use sum, we could then double click on the sum and come up with this little dialog showing us what we need to do. In this case, add some numbers together with a comma in between each one. Once you're finished, you press enter. That function is now active. So that's how you can access the functions from within the cell. There is, however, a better way to access functions if you don't know what you're looking for. So I'll just select C1, and this time I'll go up to this little insert function button near our function bar. If I click on this, it opens the insert function window. Now this has several options which are useful to us. The first one is this search function at the top here. So using the same sum function, we could start typing sum in here, say go. It'll then filter this bottom list with everything that has something to do with sum. Now talking about trigonomical functions, we might want to search for the sine function. So we could type sine, press go, and we've now found the sine. You can also select by category. Excel has all these different categories for different functions built in. So we could, for instance, maybe just go for the mathematical and trigonomical functions. In which case, that then filters this list to all those within that category. So going back to our sine, I'll just research for that. Once you have your function that you're looking for, you can click on it. This gives you more information. It tells you what you need to do and what the function does. In this case, it returns the sine of an angle, where you need to put a number into the function. If I click on another function, let's say the cos, you'll see that this changes and gives us more information. If at any point you are stuck on a function and you need more help, you can click on the help on this function. This will open up the Microsoft website, which gives you far more detailed instruction on the individual functions themselves, with worked examples and in some cases worked videos of these examples. So I'm just going to click on the sine and then say OK. This now inserts the sine function into our cell and also into our function bar at the top here. Now instead of entering our function arguments directly into the either cell or the function bar, it pops up with this function arguments window. Now depending on how many arguments your function can take, you'll have multiple different input available. In this case we have a single number input, so I'm just going to type in a number. Now note that Excel is asking for the angle in radians. Excel doesn't actually work or calculate in degrees. So every time you need to calculate in degrees, you need to convert to radians. So I'm just going to add in 1, so 1 radian, and you can see that it's showing us that 1 radian and the sine of that is 0.84, etc. So I'm just going to say OK. It's now inserted that function into the cell, giving us our result and our function up in the function bar. Now, as previously mentioned, Excel works in radians and not in degrees. This doesn't mean you can't easily convert from one to the other. So I'll just clear what we have. So we have a blank sheet, and we'll just do a work-through example using this right-angled triangle on the left. So just to remind you, in order to convert radians to degrees, we can use this equation 1 at the top, where 1 radian times 180 over pi equals 57.296 degrees. So that's the manual way of converting. We'll see in a minute that there's some built-in functions we can use as well. So on my right angle triangle here, we have our hypotenuse, our adjacent, and our opposite. So I'm just going to create a quick table here so we can add some values for these in. So an H for the hypotenuse, A for the adjacent, O for the opposite. And I'm just going to add some values. So 5 for the hypotenuse, 4 for the adjacent, and 3 for the opposite. Standard values for a right angle triangle. Now if we wanted to work out x down in the corner here, we can use any one of these three equations here, starting at equation 2 to equation 4. And each of these uses either sine, cosine, tan, and then two of the various inputs we have, either an opposite, hypotenuse, an adjacent, hypotenuse, or an opposite and an adjacent. So if we wanted to work out our x using equation 2, this is how we would do it in Excel. So I'm just going to put a title in here. This is not a function, just a title, so it's plain text. And then I'm going to do our calculations along this row. So the first thing I want to work out is what O over H would be. So in here, I am just going to do equals, choose the opposite, divided by the hypotenuse. Press enter. So that's telling me that the opposite over the hypotenuse is 0.6. Now in this next cell here, I'm going to calculate what the inverse of sine of 0.6 is in order to work out what sine x is. So I'm going to start typing with an equals, and I need to find the arc sine, so the inverse sine. In Excel, that's a sine. And you'll also find there's an a tan and an a cos as well. If you select that, I now need to enter my number, so I'm going to refer back to my 0.6 cell, and then close the bracket and press enter. Now that's calculated our value of x, but this is in radians, not in degrees. So how do we convert that from radians, I'm just going to put rad at the top here, to degrees? Well, in Excel, we have two functions for converting from radians to degrees and from degrees to radians. The first one is degree, as you can see here. This converts radians to degrees. So if we click that, click our radian value, close our brackets, press enter, this is now giving me x in degrees. If we wanted to convert back, for whatever reason, from degrees to radians, for instance, if we wanted to input our value into sine, we can select the radians function, which converts degrees to radians. So I'll just select that degree value we just calculated, put it into our radians function, and press enter. As you can see, it's produced exactly the same result as we started with over here. Now, just to prove that if we did take our radians degree and put it into a sine function, we should get our 0.6 back. And there we go. So this here, just to make it really clear, is O over H. This was O over H. And what we've done is gone through a series where we started with O over H, turn it into radians, then use the arc sine to do that, then turn that into degrees, we then turn that back to radians, we then use sine to work our OH back. And we could do this with any of these equations down here. Another useful function you'll find built into Excel is the pi function. So for this example, I'm just going to use this circle down here, and we're just going to quickly work out the area of this circle using our standard equation of area equals pi r squared. So up here, I'm just going to add in a table for r, for our radius, and a label for area. So for radius, I'm just going to choose 5 as a random value, and then we're going to put our calculations in B11. So the first thing to do is get the pi value. Now in Excel, to get pi, you just start typing pi, and it brings up this pi function. You can double click that, it'll open up a bracket, but pi doesn't actually need an input. All it's doing is returning the pi value. So you can just close that bracket and press enter. So now this is our pi value. So in order to finish the calculation, all we have to simply do is do pi, open brackets, close brackets, times the value of the radius, so refer to that cell, and we need to square that value. So I'm going to use the hat symbol, which is Shift 6 on my keyboard, and put a 2 in. So it's pi r squared. Press enter. We've now got the area calculated. So this is the pi function, which can be very useful. It saves you having to type it manually. So the next thing we're going to do, now we've covered the basic trigonomical functions, is look at the rounding functions, and in particular how they differ from the formatting of numbers we saw earlier. So I'm just going to clear this worksheet. So I selected everything. I'm just going to say clear contents. This is a quick way to do it. It clears everything under the selection. And I'm just going to increase the size of the worksheet and get rid of those examples from the side. So Excel comes with various built-in functions for rounding. So I'm just going to start by creating a little example. So we're going to have an input value. Now this input value is going to be 264,729.534. So I'm making it into a number with decimal places. And I'm going to show you how each of the different rounding functions work. So the first one is called round. This is me just typing titles in for the moment. The second one is round up. The third is round down. I'll just increase the columns. This is a quick way to increase columns to the actual width of content. You just double click on the line at the top here. And finally here, I'm going to show you what the formatted version looks like. I'm just going to bold these so they look like titles. So in order to round a number, we again start with equals, and we start typing round. And you can see we've got these rounding functions appearing. So the first one is round. So this rounds a number to a specific number of digits. So we select our number, and then we select how many digits we want to round to. So in this case, if I select 1 and say enter, you'll see it's rounded to 1 decimal place. If I then change that to 0, it's now rounding to the first full-scale integer. It's basically got rid of the decimal places and rounded up. I'll show the same example here, but with round up. So this rounds the number away from 0 in an upwards direction. So again, we can select the number. We can select the number of digits we want to round to. In this case, I'm just going to use the same example and use 0. Say enter, and we get the same number. Now if I use the round down function, so start typing round, find round down, select the same number, 0 again for the number of decimal places, you'll see that instead of rounding up, it's just rounded down to the nearest integer. And over here, I'm just going to say equals and select this cell. This will copy the cell data exactly across to this one over here. And this time, I'm just going to use our formatting options. So I'm going to remove the number of decimal places we see in order to round visually this number to the same as we have across here. Now visually, this number over here, which is us using our formatting options rather than a function, looks exactly the same as our round and our round up. However, that's not exactly true. It's only visually appearing to be that number. So what I'm going to do to prove this is to add 1 to every number. I'm just going to add a title here. Add +1 colon. And then along here on our row 5, I'm just going to have a simple equation. So equals, select the value above and say +1. And we're going to have the same for every value along here. Now, when we look at these values, you can see that this value has added 1, this is added 1, this is added 1. These are all correct. We look at this, this looks like it's correct. So it's added 1 onto the number at the top. However, if we go across here and then we start increasing the number of decimal places we can see, I'm just going to increase the column width, and do the same for every value along here. You'll see that all these values here are correct. But this one still has the original decimal places that we have hiding from our number over here. So this formatted number here is only hiding visually our decimal places and rounding it. The actual underlying number is still our original number over here with decimal places. Now this might not seem a very important point. However, if you're only formatting your numbers using our visual appearance formatting, and then you do a calculation assuming that that is the number you're actually using in the calculation and not this number here, your calculation results will be wrong. So if you are doing rounding and it's rounding for non-visual appearances, so for using a calculation, always use one of these rounding functions instead. So next we're going to look at pseudo random number generation in Excel. There's a couple of useful functions which we can use to generate these random numbers. And these are useful in some computer simulations, such as the Monte Carlo simulations. So I'll just clear out this example. Again, select everything, say clear contents. And the first random function, or number generating function, we're going to use is the rand function. And this generates a random number between 0, or it could be 0 itself, so it can equal 0, and it's got to be less than 1. So if I double click that, close the brackets, because it doesn't need an input, press enter. And it's generated this random number for us. So it's a number between 0, or could equal 0, and below 1. Now every time you want to generate a new random number in Excel, all you have to do is press the F9 button on your keyboard. And you'll see that it's recalculating a new random number every time I press the F9. So this is what we call a pseudo-random number. All that means is that it's not truly random. So for truly random numbers, you'd need to use something more substantial, such as a quantum number generator. Whereas Excel actually has a function that's hiding in the background to create this number. So because it's got a function and a calculation, this number can actually be worked out. However, the way the function works is that it's so complicated that you'd need a huge amount of computer processing power to actually work out the pattern. So that's why we call it a pseudo-random number rather than a random number. Now the other random function that can be useful is the rand between. And this allows you to specify the top and bottom range of the numbers it generates. So if you want a bottom number, we could have something like 10 and a top number of 50. Close the brackets, press enter. Now every time it randomly generates a number, so I'm just going to press F9 a couple of times, it'll create a number between that range of 10 to 50. Again, this is very useful if you want to create a computer simulation where you have random inputs into your system. In a more worked example, and I've just opened up this file called dice roll example, what I've done is use the rand between function, and put random between 1 and 6. So that's our standard dice numbers. And because the rand between can throw out a number that has decimal places, I'm using the int function. So this turns the number with decimal places into an integer. And I have this same function 6 times. So this is simulating 6 dice rolls. So every time I press the F9 button, it re-rolls those dice for me. So this is one way you could use Excel to simulate some form of card game or some form of chance game where you have a stimulated dice roll input. So the last set of functions I want to cover in this demonstration are the basic statistical ones. So for that, I'm just going to come down here and open up some data in another Excel worksheet. And this is a set of crater data. So we've got the diameters of the crater and the depth of the crater. And what we want to do is calculate the min, the max, the minimum, the maximum for both the diameter and the depth, the mean, the mode, and the median. So how do we do this in Excel? Well, there are functions for all these various values we want to calculate. So the first one I'll look at is the min function. So if you start typing min, what it will do is it will find the smallest value in a set of data you give it. So you can either give each individual number, a bit like the sum by going down, or we can give it a range of numbers. So in this case, I'm going to give it the full range of numbers for the diameter just by clicking and dragging to highlight that column. And you can see that it's gone and put in A2 colon A26, which is our range of values. I can close the brackets and press enter. And now this is going through all our values and finding the minimum value. The opposite, of course, would be a maximum value, and that's the max function. Again, it works in exactly the same way. You can input a range of numbers or individually type numbers in. Once you're happy, press enter, and it's now calculated the highest value for our diameters. If we were to do that on the depth using the min, it works in exactly the same way. So very quickly, we've worked out the minimum and the maximum values for both our columns here. If we wanted to work out an average or a mean of one of these columns, how do we do it? Well, again, we've got built-in functions. So in Excel, the mean value is called average. So you need to start typing average in. You'll find the average function. Let's work out the average of diameters so we can then select our range of values. And a bit like the min and max, once you've got the range of values in there, you can close the brackets and press enter. Now what it's done is it's gone through and added up all these values. It's worked out that there are 25 of them, so it's taken the added value and divided it by 25 to give us our new value. Now we could do that manually. Another useful function is the mode. And this is found using the mode function down here. Once you have the mode function up, you can select your data, close your brackets, and press enter. And this has found the mode. Now the median, again, there's a median function. You start typing a median in. Once you have that, you can select your column of data, close your brackets, and you get the median out. And these are our basic statistical functions for dealing with large amounts of data, where we want to find averages, modes, and medians, minimum and maximums. As you can see, it's really easy to use, and is a lot quicker than trying to manually work out some of these.